Okay, welcome again to the second lab for this class. We're in Physics 11. And there was some questions before we actually started the recording concerning the units for the first lab. And I said the answer to that, and I'm trying to repeat this one actually for the benefit of the people who are not here or later watching this video, is that you can use either. You can use what the GeoGebra is giving you, which is in meters, or you convert them, but at the end, you're going to keep them in meters because the units for the velocity are actually meter per second. So that was the question. The other question also is that the lab is not going to change the due date on it. So it's still 11 p.m. tonight when it's due. So please finish what you can finish. If there is a question that is not clear for you, just leave it the way it is. It's better to get a grade than no grade at all. So that's basically the moral of the story in here. And then also, I mentioned also the fact that I dropped the lowest grade. So just basically, this is like if you want to, you can consider it as a warm-up. From now on, here is a plan. You will see the lab before we actually come to it. So my suggestion for you is try to go through the lab before we come in here. You may, and there will be discrepancies like this one. The lab instruction is giving it in centimeters for lab 1, for example, and the data you're receiving is actually in meters. So there could be something like this one, confusion. So you'd want to try to see this beforehand so that we fix it before it's too late. That's one thing. And also be ready for the lab. This is how we do it actually in the face-to-face too. We give the lab before the actual lab, and you go through the lab. There were questions called pre-lab questions where you're supposed to ask them before coming to the actual lab. Then you do the lab, and there are some post-lab activities that you also do. But because of this COVID thing, basically what I'm asking that you do, guys, is go through the lab as much as you can. I know sometimes it's a new and you have no idea what the lab is talking about, and it may be too much, but try your best to go through it at least once, okay? Now, there are some concepts that these labs are drawing from the Physics 10. You guys who are in Physics 10, you should review the content from Physics 10. Those who took Physics 10 in the past, they should actually go and review those concepts. For example, today, the concept of vectors, and that's because forces are vectors and the velocities are vectors, and at some point, we're going to be adding vectors and dealing with vectors. So the whole lab today is basically about vectors and how we add them and how we do them. So that is something that you need to do beforehand. Also, during the lab, we're going to go live for about an hour or so. Then you still have 2 hours or 2 hours and 10 minutes to actually complete the activity. So my suggestion for you guys is don't leave after we're done with the recording. Stay on your lab. Stay working on it. Shoot me an email. If you need be, we can go back live. We can go back live. A question like, okay, this question is saying, but it's not clear. I know we talked about it during the live session, but for some reason it's not working out. So during our lab session, because when we meet actually face-to-face, this is what we do. We go through the little bit of instructions and how the lab works, and actually you start doing lab. And we would not leave until it's 9:10. So basically, that's the intent with it too, is that you have to spend at least the allotted time for the lab, finishing the lab. Now, for some reason, you cannot make the live session or you have to go, you still have to start on it right away. Do not leave it until like Wednesday when you discover, oh, there is a lot of things to be done. And there are a lot of things to be done. Okay, there is so many things that you have to go through for a lab. So you have to complete those sessions. So the sooner you start on it, the better you're in shape, in good shape. You formulate already a plan on how to tackle these issues. You see the different components, what needs to be done. You have a clear idea of what to do. Then you finish them, hopefully a day before the actual when the lab is due, or at worst, the day when it's due. Okay, and you submit your lab and you're done with it. Usually, for a 3-hour lab, you need at least this many hours to work outside of a lab to complete it. If you find yourself spending too much time, that is the time when you shoot me an email or you go to Pronto or one of those things, which is actually available for you on Canvas, and send me a message saying, okay, can we talk about this one? Like one of you guys did last time, which was fine with me. We went basically on on Canvas, on Zoom, and we went live, I think, for about 15 minutes or so. We discussed the thing, and then I recorded it, and for the benefit of everybody else, I posted it again. So try to have this working format, basically, in terms of how these labs are proceeding. Okay? Yes? Jeffrey, Diana, Amanda. There are two Amandas in here. Okay, Okay, very good. So I know a lot of you are not here today. Let me get into the chat thing. I forgot to turn it on. Oh, there are a lot of yeses in there. Okay. Okay, so let me get into the lab today. Okay. And before I do the lab, I want to go through the lab instructions because I want you to see something in there that is going to be critical for this lab. If you don't grasp it, you're going to have difficulty with it. This is physics. Let me find the course first of all, physics 11. And let me go to the models. And let me find where the lab 2 is, vectors and equilibrium. And let me share my screen, okay? Let me go back in here. Share screen. Okay, it gives you the same similar instructions basically in what needs to be done. This lab is due a week from today, 11 p.m. Okay, so basically, and also don't forget you have a rubric in here. Oh, I'm sorry, the rubric is on the bottom in here. Okay, so you need to follow the rubric in preparing your lab. Make sure the table is there. The table is worth 45 points if it includes pictures. If it doesn't include pictures or it's missing stuff, so it can drop as low as basically no points. So, and I will tell you what those pictures are. And the pictures need to be separate. They cannot be inside the PDF file. I tried that with another class where I had the file read pictures, and then the whole file became basically non-fillable, which is bad, okay? So I have two pictures in here. This is what I want from you. This is the sample project that I have. At some point, you're gonna do a graphical sum, this method. At some point, you're going to do a computer-generated sum, which I'm going to show you how to do. And at some point, you're going to do the table force, which is going to take you to the GeoGebra where you're going to do the table force. So those are the three ways we're going to do to add vectors, okay, and find the sums. This is one of them. I'm not going to go into the details about this one yet, but I will go through it very quickly. But I have two images in here. And I hope you guys, did everybody see these images before coming to class or not? Did some people see it or not? See them or not? Okay, you guys saw them. Did you notice any difference between the pictures for those who did see, oh, did not see them? They're actually on Canvas. Okay. Can you have a quick look at them and tell me if you notice any difference between the two pictures, at least visually? Do you see any difference visually? Let me go back to them. Okay, this is the top picture. It says example. It gives you the angle in here that I measured with protractor to be 25 degrees. It gives you the length of this one. It says 120 grams. It gives you this one, which is 50 grams. It gives you this one, which is 100 grams. It gives you this angle also by protractor to being 80 degrees. And it gives you a scale in here, 10 grams going for per centimeter. Okay. Yeah, that's the intent. Thank you very much, Amanda. That is the whole point. That they should look similar, identical. I mean, if you are very picky and careful, this one looks sharper, okay? But they're readable in terms of content. I mean, this, for example, PETE or something, the brand of this ruler is sharper in here. You can clearly see it than this picture, for example, okay? But other than that, the scale looks fine on the second picture. The details, the information that this basically graph portrays are the same as this graph also portrays. Both of them, they portray the same information. And that is the whole point of this one. I took them using my cell phone, which honestly, I'm not too happy with it. This is a Apple phone. I used it to take pictures with it, okay? I didn't know how to basically reduce resolution on this thing in here. Probably there is something in the settings in there, but it's kind of convoluted to get to it. I have other phones. I have, for example, this Windows phone. This one is very easy to change the setting on it and take the pictures. My point in here, if you have probably an Android phone, it's easy for you to change the setting on the phone and make it into web picture. When you say a web, the resolution drops, but it's still fine. I can see it, you can see it. It's going to be readable 100%, but the file will be very, very light. It uploads very quickly. So when I'm trying to grade it, it also very fast. It loads very fast for me, so I know exactly what you're doing. And it portrays the same amount of information. A picture that is taken at a high resolution brings very little addition, but it comes at tremendous cost in terms of bandwidth. As a matter of fact, what I did in here, and let me stop sharing the screen with you guys. If you have Photoshop, you're in very good shape. You can actually still take it with a high resolution camera or a phone, but actually reduce its size with Photoshop. I don't have Photoshop because it costs a ton of money. So what I ended up doing, I ended up getting something called GIMP. GIMP is a freeware. If I can find it in here. Yeah, here it is. So I used GIMP basically to reduce the size. After you load it into GIMP, all you have to do is just go to the image and what is image size? Resize the picture or something in here, okay? And now I can't find it. This is the canvas. This is the size of the area in here. Here, scale image, okay? You go to scale image. Right now, I dropped it to 600 by 800. I could have dropped it further by 480 by something. It still works fine, okay? But just for 600 by 800 pixels, the picture looks very good. 95K is very small compared to the original size, which was 4,000 times 3,000 or something, which was so big. I mean, it's ridiculous. So my point in here is, for this whole purpose in here, once you get a picture, try to optimize it for the web, either through the phone setting, or if you can, through a software like GIMP, okay, which is a freeware, okay? Now, if you choose not to do that, understand that your file may not load properly. It may take too long for you to upload and put you outside of the deadline, or it may take for sometimes too long, or sometimes it crops actually on it comes in here and stops. Okay, does not load the whole thing. It's not fault from my end. It's not basically somewhere in Canvas. Sometimes they don't like this big size. You are limited actually in terms of size what you can do. So my suggestion for you is you do this. So to answer today's prompt, remember, we're supposed to answer questions for our live sessions. So when we go today, so how do we handle pictures? Optimize them, make them smaller, okay? So either one of these things, that is the answer to today's prompt. Do you guys understand this question or not? Yes? Very good. GIMP, it's a GIMP. I don't know about XGIMP. I have never heard of that. Is a freeware. Yes, you can download and play with it. Look, it's like Photoshop, and it's actually a good tool to have. I mean, I'll enjoy it too. I mean, you can do a lot of basically touching pictures and playing with it and doing things like that. Photoshop costs a ton of money. I mean, I know the campus, I think they have a freeware for it or something, but yeah, there are some other software, okay, for optimization. There is online places actually you can go and reduce the size. So whatever you do, the answer to today's prompt was, can anybody tell me what it was again? So when you go today after the class, and it's going to ask you, what was the answer to today's question or questions? The answer is? Okay, very good. Optimize photos or make them smaller, okay? Because they're not going to work well with any other format. Very good. Yes? Do I have everybody on board now in here? I'm going to talk to you about the lab and how the lab works. But I just want to take your attention to this technical issue because you are required to upload pictures for this lab. and the pictures are all going to be of this type. Basically, you're going to grab a ruler, a protractor, you're going to draw vectors, use a pencil, try to have it a sharp pencil, okay? I sharpened this one, and make sure your measurements are accurate, and show me the scale, okay? Show me the scale. If you don't show me the scale, I have no idea. You could be drawing a whatever you like in there. It doesn't make sense, okay? So for example, if I use this ruler, if I take GIMP actually and tell it to how many this versus that, I should see this is 10 of that. So it can actually help me check your work, that actually this is 10 times this. 10 times 10 is 100 grams. And I check also this length, and I check to be actually 50 grams also. I check this length, and it's 120 grams. There is no need for me, if you have all the length correct, to check the angles, because then this is triangle identity. There is a triangle relationship that can tell me what the angle was. And then I can infer if you use a protractor to find that angle or not, okay? By that time, if you did this length correct, then the angle also should fit correctly, okay? But I need the scale. So when we're gonna go through the graphical method in more detail, but I need all of this plus the scale, okay? Try again to bring me this picture. This is beautiful. This is perfect. I don't want to read all the details about who made that ruler. That's not relevant for me. All I need to see is that showing me the scale. The scale on this scale, and this thing, it says for every 10 grams is a 1 centimeter, or 1 centimeter is equivalent to 10 grams, okay? So that's basically what people do also on maps. They show you a map, for example, of the city of Riverside, and it's drawn, and they give you the scale for each, how many, for every inches, how many miles that is. So you know how to convert and find the actual distance between, for example, RCC, the city college, and, for example, Norco, just using the proper scale. So I need the scale when you do that, okay? For this scale, they're not all the same scales, by the way. They can be 5 grams per centimeter. If the picture is too small, then you need to probably blow it a little bit. And maybe if it's too big, then you probably need to make maybe 20 grams per centimeter to bring it to close, okay? So the scale is critical when you're doing this one, because it helps me make sure you drew it with the proper tools, okay? So that's in a nutshell what these pictures are. So you have the prompt for today's discussion, and now let's go through the lab. So you're supposed to download this instructions. Let me see if do I have a lab to open in here in my things or not. Let me. Okay, I'm gonna download it in here and open it with Adobe. One of you sent me a question today about whether or not you are required, if you find a way of doing these files without Adobe Reader. Are you required to do Adobe Reader? No. As long as it saves whatever you do, okay? Whatever you do is saved in your okay, I mentioned something about the rubric, so you guys make sure you go through the rubric. The name now is required, okay? So it's going to be graded. If you forget to put your name, whether you submit this form or another form or whatever report that you're going to submit, you need your name on top of that, okay? In addition to that, I need the name or names of the people that you worked with. Remember, I encourage people to work together in labs, so please put the name of everybody who works with you too. So in this case, you put your name and you add an append to it, an attachment saying that so-and-so worked with me, okay? No, only on the main page, on the title page, okay? So the question was, do I have to put it on every single page? No, only on one page, okay? So usually, like I said, I defer the objective to a little bit later after you have a full understanding of what the lab is. Then you can put your hypothesis. At this point, probably we don't know what we're doing. So we're talking in here about vectors as being quantities that are have two numbers attached to them, and magnitude and direction. Case in point, the force, for example, has the strength of the force and the direction in which the force is applied. Velocity also has a magnitude, which is the speed, and also direction of where the object is going, okay? So those are examples. This is how the vectors are represented in geometry. They actually have an arrow, and the length of the arrow is usually proportional to the strength or the magnitude of the vector. The angle with which, this is critical, the angle with which a vector makes with the x-axis is actually the direction. So it's an angle measured in, usually it's measured in day-to-day talk, we measure them in degrees, but actually they are measured in radians more appropriately. So let me get into the comments, if I can get one of the comments too. So this would be the x-axis, okay? And the angle is this angle. Do we have a tool in here to draw curved shapes? What happened? Okay, this is the angle. It's between the red line and the arrow for the case of vector A. For the case of vector B, you have to be very careful, okay? The angle is going around, going over 90 degrees, coming above 180 degrees, exceeding 270 degrees, and going back in here. So the angle is not this one. It's always starting from the red going to the vector. In here, going from the red to the vector is less than 90 degrees. It's somewhere, this is probably 60-degree angle, okay? This one is 270 plus. It's probably 285 degrees or something. Now, for this vector C, again, the angle, the direction for this vector C is starting from the red axis, which is the x-axis, east-west, and going, exceeding 90 degrees, exceeding 180 degrees, and in this case, probably 220 or 230 degrees, okay? So always counterclockwise. The key word in here is that angles are measured counterclockwise, against the clock. This is the positive direction for the angles, okay? If you go clockwise, that is actually a negative angle, okay? Angles are they have positive and negative, so they represent direction, as a matter of fact, okay? The unit for the angles is degrees, but more appropriately, it's actually in radians, and 1 degree is the same thing as, what is it, 180 times the angle in radians divided by pi, okay, times the angle in radians. So this is your conversion factor, okay? Not the angle, not the vectors are measured counterclockwise, okay? The angles are measured counterclockwise. The direction of the vector. So the correct answer is the direction of the vector is positive when counterclockwise. Counterclockwise. The point being in here is you have to be careful. You can still go clockwise as long as you append a negative number to it, okay? And if you have a calculator, you can, for example, calculate an angle and it's going to give you a negative value. So there is no problem with that. But that means if it's a negative value, you have to go in the opposite direction, okay? So if I go clockwise for the case of C, I'm going to find probably negative, what is it, 160, for example, or negative 130, for example. If this is 230, this should be negative 130, okay? For a total of 360. So that's basically how this works. But note the following, and that's critical. 230 is the same thing, equal to negative 130. Because it's the same angle. I mean, if you tell somebody I have negative 130 and it's equal to positive 230, that person would not know what you're talking about unless you're talking about degrees, angles. There is something you need to be aware of when you come to angles. Angles are actually on a circle. Okay? This is the trig circle, okay? And it starts from 0, goes to 90, goes to 180, comes to 270, and goes back to 360, which is the same as 0. You start over again, okay? And 360 plus 90, that's what? For 450? 450 will end up in here, or 90, it's the same thing. So basically you can go in circle like this one, okay? Or you can go clockwise. How the clock goes, this will become negative 90, which is 270. This becomes negative 180, which is positive 180, same thing. Or this is negative 270, which is just positive 90. And this becomes negative 360, which is the same thing as 0. So basically, that is the angles, okay? You have to be very careful with how these things are represented. But the direction is always measured with respect to the x-axis, to the east-west direction, where the east is the positive direction coming from the west, okay? So that's how directions are measured. For example, in here, there are different representations of vectors since we need its magnitude and direction. It's the pair of these two numbers that define a vector, direction and magnitude. So if somebody tells you, I'm driving 50 miles per hour, okay, I'm walking, let's say, for example, the person went on a hiking trip, and he said, you know what? I've been walking for 10 miles per hour, basically jogging, and can you tell me where I'm at? I left 2 hours early. But if the person doesn't give you any direction, you have no idea. First of all, did that person keep a straight line or go in a zigzag pattern? Or went and back? He could have ended up being back to where he started from. So you need the direction. That's why the velocity is a vector, not a scalar. But if they tell you the person, the temperature right now is 83 degrees, you don't need direction for the temperature. It's 83 degrees. It's not, has no direction. It's just a temperature. It's just the number. Or somebody tells you this object weighs 50 kilograms. You don't need a direction for the mass. It's a scalar. So that's the difference between a scalar and a vector. So vectors are critical concepts that happen to be that way. So again, this is basically the example telling you about how the person went on a high, going 3 meters per second, 30 degrees. And again, the degrees are measured from with respect to the x-axis, going 10 steps one way, 10 steps the other way. Here is the thing. Let's say, for example, your objective is to reach this point. There are several ways of making it to that point. Either you take 10 steps this way, or 10 steps the north, or you can go 10 steps north and then go 10 steps east. In either case, it's the same thing as going straight 14 steps forward. Of course, somebody else can go like this. Somebody else can go vector like this one, and then, and comes back. So there are so many ways of getting to the point when it comes to space. That's why vectors are very critical. But in this example, a 10-step east followed by 10-step north is the same thing as 14 steps going straight. And that's how you add up vectors. That is, again, the graph that I showed you, the pictures that I showed you on how to take vectors. I mean, how to take to add vectors. So the same thing as going 10 steps east followed by 10 steps north is the same as going from your starting point to the ending point of the starting point of the first vector to the ending point of the second vector, okay? Provided you shift one of the other vectors, okay? So let's say, for example, somebody gave you this vectors. I have this vector, and I have this vector, and I want to add them up. So the first thing you do is grab one of them and draw it on top of the other. So if I do it this way, the resulting vector is from here to here, okay? Or, if I can go back, my computer is not responding. Are you guys still there? Or if I can go back, there is another way of adding the same vectors, starting from this vector, and this is how this vector was. I can draw the second vector and end up with the same sum, okay? Vector does not care where you start from or where you end to. What it cares for is just magnitude and length. That's why if I take this vector and put it anywhere, I did not change it. It's still the same vector. That's why I can shift them and put them the starting point and line them up however I want to, and I will end up with this sum, or line them up differently. Let's keep them basically in such a way. Let me see if I can get this. Keep this one in here and line them up the same way and end up with this sum, which is just the same vector I did the first time, shifted this way, that's all, okay? So translated vector, if it keeps its magnitude and direction, is the same vector. So this is some of the background that I really want you guys to have a full understanding of what vectors are and how to add them up and all. Now the graphical method is exactly what I was describing. Draw one of the vectors, okay? Go to the end of the second vector and draw a parallel to the vector that you want to add. Let's say, for example, I know this vector has a length of 100 Newton and it has a direction of 120. So I'm going to draw from the start. First of all, the direction, and use a protractor to find where the other end needs to be. 100 and, how did I say 120? 120 this angle. And then draw the length with the ruler of how much I need. Now I have drawn the second vector at the end of the first vector. Now go from the beginning of the first vector to the end of the second vector, and I'm done. This is the sum, how I do it. Let me stop this one and go back into the screen that I shared with you from Canvas. In this case, I have two vectors. They're coming straight out from the table, by the way. One of them is 100 grams Newton, because in here I am tying 100 grams to a string times 10. That's 0.1 times 10. So in newtons is actually equal to 1 Newton. Okay, but I'm representing the force in here in grams, which is fine as long as I keep the units the same. So 100 grams in this case. In zero direction, the angle is 0. So this must be parallel to the x-axis. So there is no, it has no y components. It's only in the x-axis. Now that's one vector. So I draw the vector 1. Then I go 80 degrees from the end of the first vector and draw. So this is 80 degrees. This is what protractor was telling me 80 degrees it needs to be. This is the direction of the 80 degrees. And now it tells me to draw a 50 gram. According to the scale, this should be about 5 centimeters, okay? So I draw 5 centimeters, and then I draw the line from the beginning to the end, and measure this line with the ruler. I have to measure this line now, okay? What was given to me is the 100 grams and the 50 grams and the direction of both vectors. I draw those first, and then connect the two. Use the ruler. This was about 12 centimeters when I used the ruler. Multiplied by my scale, 12 times 10 is 120. So 120 grams, okay? The actual measurement with the ruler was 12 centimeters. 12 centimeters times 10 grams per centimeter, cancel the centimeter, end up with 120 grams. So my answer is, the answer in here is 120 grams. Then I use a protractor again and measure this angle. And I found it to be about 25 degrees, okay? That's it. Or alternatively, what I could have done is the following. I could have drawn the 50 gram first at an 80 degrees from the x-axis. So I could have drawn this vector first, and then at the end of that vector, draw the second one, which is at 0 degrees. That means parallel to the x-axis, of length equal to 100 grams. I would end up in the same point. Either going this way and then there, I would have traveled to this point, or going this and then travel there, I would end up in the same point. Using the same ruler, I would have found the same length, and using protractor, I would have found the same angle, and I report that in my table. Do you guys understand the graphical rule? Now somebody asks, and it's a valid question, what if I have 3 vectors? Well, you do the first 2, pick any 2 you like. Although in the lab, it tells you to use vector A and then B and vector C. So keep that order if you want to. Start with A first, draw vector B, and find their sum, resultant, and then use the resultant to add it to whatever the new vector is. and then find the resultant of everybody. The question from Amanda is, so it doesn't matter what an end of the x-axis you put your 50 grams vector. It matters the order only with which you start. If you started with the 100 gram vector, which is vector A, then the starting point for the 50 gram has no choice. You have no choice in the matter. You have to put it in here. And the direction, you have no choice in it either. That is an 80-degree direction. That is no choice. That protractor tells you which direction. How long that vector need to be, you also have no choice at that point because it's a 50 gram. According to this scale, it's 5 centimeters. So this length has to be 5 centimeters, okay? With the ruler. Now I know where this vector is. Then at that point, I know what the resultant is, correct? I have done 2 vectors. If it is 3 vectors, I use the first 2 first, and then starting from the end of the resultant, the first resultant, I add the 3rd vector. Let me see if I can bring the screen down. Let's say, for example, I have another vector going this way. It has a 100. So from here, I have an x-axis somewhere, and I add to it the other vector. Let's say, for example, it's pointing down. So the new resultant will be here, okay? So again, it should be in the instructions on how to handle 3 or more. If you have difficulty with it, please let me know. I will do actually the 3 vector example, okay? But I'm just following the stuff that we do normally. Did you guys do some summation of vectors when you did physics 10, or we didn't do it actually in this class too? We just go briefly on it. The resultant is the sum of the vectors, and that's it. No? Okay. So here is the practice. That's really why you are in this class, is because you want to practice this on how to add vectors, okay? You have to practice this thing in here. Okay, so basically that's the key thing in here. Okay. Let me go with the instructions again. Let me pull another thing in here just to show you something in here. Let me pull another screen in here where I can draw freely in here. So let me draw. Can I draw lines? Yeah, I can draw lines. Okay. So I have vector 1. Let's say, for example, this is my vector 1. I'm going to draw vector 2. So this is making an angle with respect to the x-axis. So I'm going to make an angle with respect to the x-axis. Oops, Control Z. So this would be the x-axis, okay? So I'm assuming that there is an angle in here. So I draw the second vector now. Let me pick up another color. Oops, you guys are not looking at what I'm looking at. Sorry. Should mention these things. Okay, where is the Okay, very good. Okay, let me find where my screen is. Sorry for not sharing that stuff in there. You guys need to turn on the voice if you see me drifting and going forever and ever. Okay, where is it? Here. Okay. You guys see? I drew with the red one the x-axis. I used a tool in here to draw a vector. Okay, so this is vector 1. So it's making an angle in here of some sort, and here is the angle. Oops, Control Z. Here is the angle. Let's assume that this is, for the sake of argument, 30 degrees with the protractor. Okay, I was able to see it and it's for 30 degrees. And the second vector, let's say, for example, for the sake of argument, it's 120 degrees. Okay, and it's shorter than this one because I don't think I have real estate in the top in there. I'm going to draw a second vector, and let me pick up a blue color for the second vector. But before I do that, I want to draw, first of all, the x-axis in here. Okay, so this is the x-axis again, just to give me a reference for the second vector. And I just said the second vector need to be 120 degrees. So this is 90 degrees. This is roughly 120. No, this is actually more. This is about 120 degrees, okay? So I'm going to draw a vector now of about 120 degrees, which is this much. The resultant of these 2 vectors is going to be, let me get a thicker line in here. So this is the resultant, okay, of the two vectors. So if I'm careful with this angle being 120 degrees with the protractor, and this is 30 degrees, this is the resultant of these two vectors. Let's say, for example, we have actually a third vector added to them, and the third vector happened to have 100 and, let's say, for example, 212, okay? Again, I go where the resultant was last time, where the last point is, we ended up in here. So I need to draw it from this point now. So first I need to draw the x-axis, and here is the x-axis. Just to make sure I have a reference for the x-axis. And now I'm going to pick up another color if I have another color. Do I have another color? No. I'm going to use the green again if you guys don't mind. So remember, I said 230 degrees, for example, or 240 degrees. So this is 90 degrees. This is 180 degrees. And this is roughly, or let's make it a little bigger, okay? Or 260 degrees. 260 degrees, just less than 207 degrees. So this is actually the third vector. And I'm going to draw it in here. So this is the third vector. And let's give it a long length, okay? So this is the third vector that we need to find the sum of this one plus this one plus this one. So I added the first two first. I ended up with this guy. And now add to them this vector, the third vector to the mixed. And now my actual resultant is going to be, here is the resultant. This vector. From the starting of all to where the last vector ended. So now you're curious to know its magnitude. Use just the ruler to find it. Use the ruler. How long is this blue line? And convert it with your scale to the proper units. And then you want to know its direction. It's very easy. Then in this case, just basically use a protractor and find this angle. Of course, the protractor can go only to 180 degrees. So what you do in this case, you find it from here, find this measurement, and subtract it from 360. Because this whole thing, whole cycle, is 360. Going from here, I'm sorry, 360. So if your calculator, if your protractor is giving you this much, so you want to know this whole thing, you just deduct that number from 360, and you're done. So this is in the case. I gave you a little bit complicated picture so that you guys have an understanding of how this addition of the vectors is. Does this illustrate a little bit? I know that some of you probably will be coming back to this video to look at it to make sure that you have a visual of how this vector addition is when you have more than two. When you have two, is a little bit easier than when you have more than two. But that's actually explained in the instructions. Does this help a little? Yes? Okay, very good. Okay, so I would recommend that you come back, ask questions, don't leave them toward the end and you're still struggling with them. I really don't like that. Ask questions again, and sometimes it helps to come up with another example. The first example was not probably clear. The second example or analogy will usually help something in there, okay? So that's basically how you add them graphical. This is what I was talking about, the graphical method. And this is the illustration of how to add them A, B. You go from here to here, and then you find A plus B, or you go from B and then you add to A, and the result is the same, okay? This is the operation I was talking about. This is actually the same thing, adding one vector at 30-degree angle. This is actually to scale this picture. Okay. Okay, so let's do another example. That's fine. Let's do this example, okay? Let's try to do this example together. So basically, I have an angle in here of 30 degrees. But of course, I don't have protractor on the screen, so I'm not going to be able to measure it, okay? And I have a 60 degrees, and I should find that vector in there, okay? So let's stop sharing that screen and go back in here, share that screen. Are you guys looking at the OneNote, whatever is that thing there. Yes? Okay, so I'm going to take the first thing usually I like to do is show where the x-axis is. X-axis, as I said, is the horizontal line. That is my starting point, because without which I cannot really, I drew it earlier in red. Let me stick with the same convention of colors, okay? Okay, so this is my x-axis. And every time I need to move from it to another place, I'm going. So the first thing they tell me, I have, for example, a vector of a given length. Let's give it, for example, it doesn't matter what the length is, but it's 30-degree angle. So I use the protractor first to find where that 30-degree angle, okay? So I need to find where the 30-degree angle. According to the protractor, probably this is the direction more or less of 30 degrees. Probably it's in here, okay? So this is the direction of 30 degrees, okay? Now I go with the ruler now and draw an actual vector of length 30 degrees, okay? Of a direction 30 degrees, but of a length that is different. Whatever is, okay, so it's parallel to that. Of course, in your case, you're going to draw it exactly on it, okay? You don't have to draw the direction, by the way, as long as you know the direction. So this thing in here is not needed for it, but as long as you know that that vector makes a 30-degree angle with the x-axis, you're in good shape. So we drew one vector. The second vector says, for example, that it's 60 degrees. So I'm going to come back in here and draw my x-axis. Okay, here is the x-axis. I have to actually draw it from, okay, it doesn't move. Okay, I don't like that. This is a snapping to the grid, and it's not giving me a chance to draw it from where I want to. Okay, good. Almost. There is a grid behind it. It's not. So assuming this is the x-axis, then I'm going to make a 60-degree angle for the second vector. So this is the second vector whose, sorry, let me keep with the green light in here to just give the illustration. So I'm going to draw a 60-degree angle, another vector. Here is my second vector. Okay. Not necessarily the same length, but starting from where the first vector ended. There is a snapping issue with this graph in here, but hopefully you guys see the point. Now, adding the two vectors is just adding them how we would add them basically from the beginning of the first vector, here it is, to the end of the second vector. And this is the sum. How do I know how much this sum is? All I have to do is use the ruler now. So use the ruler to find how long this vector is. Multiplied by the scale, I know how much the actual sum is. Use the protractor again against the x-axis, and I know the direction of this sum where it is. Does this make sense a little bit better?
Just to be clear, the sum is the vector we get from the 30 and the 60, right?
Yes, that's the sum of the two vectors, yes. It's a
That's
good
like
idea.
the 10 step by 10 step and then just going 14 steps, right?
Yes, the 14th step is the sum, is the resultant, it's called.
Okay.
Okay?
Cool.
Yeah, the sum changes. V changes depending on the two vectors. We're going to go through the table and see how it's going to work for the table, okay? This is one method. Okay, so let's continue now with the second part of the assignment. This is giving you some examples on how to convert to newtons and all of that. And now with a scalar, what is a scalar and what is a vector? So you should be able to tell from the instructions basically what a scalar and vector is. Basically a scalar is just a number like the mass. I gave the example and temperature and all of that. A vector is a quantity that has direction in addition to a magnitude. Okay? What is a resultant? The resultant is the sum of vectors, two or more vectors basically. Okay? And in here is where I cross the Excel spreadsheet because you're going to do the computer method using actually a program which is actually on this file in here. In the picture I drew, and I showed you actually it's on canvas, I have 100 grams, sitting at 0 degrees. I have 50 grams sitting at 80 degrees. So in here you have the magnitude, and here you have the direction. I don't have a third vector. That's why it's 0, 0 in this case, vector C. The resultant, remember, according to my measurements, came to, with the ruler, 120. This one, according to my ruler, my protractor, came to about 25 degrees. So I go to this table. Where is the table? It should be the last page. Here is with the table. The first vector, vector A, is 120, sitting at 0 degrees. The second vector is 50 grams, sitting at 80 degrees. The sum, according to me, it's 120, according to my own measurement, okay? But this is a sample. You're not going to change this value. Leave it at 119. Don't worry about this part. According to my measurement, it was 25 degrees, okay? So that is the graphical method. So now I'm going to do 100 grams at 0 degrees and 100 grams at 90 degrees. Okay? So that's one other setup that we need to do. Basically, on the x-axis, you draw 100 grams, and the y-axis, you draw 100 grams, and then shift one of them to the other, and you add them up. Okay? Use the ruler to find how much they are, and use the protractor to find the direction. The second trial, you're going to do 50 grams with 50 degrees. So now 50 grams is not sitting on the x-axis, but it's making 50 degrees with the x-axis. But it's only 50 grams. In my scale, it's going to be 5 centimeters. And then 100 grams, which is on my scale, going to be 10 centimeters. I have 165 degrees, more than 90, but less than 180. So draw the other vector, and then connect the two. Use the ruler to find how much the sum is. Use a protractor to find how much the sum is. In the third exercise, you have 100 grams sitting at 0 degrees, and you have 100 grams sitting at 240 degrees. It's more than 90, more than 180, more than less than 270 by 30 degrees. Okay, and again, so one of them is on the x-axis. That's the first one. The other one is actually pointing this way. So the sum is going to be between this and that. So you're going to be from here to here. Okay, that is your sum of the vector. Okay, you're going to find its direction and its magnitude. Question on the chat?
And you said we would basically just take away that area from 360, right? Because I mean, we can't. That's the only way that we could draw that sum through there, right?
You can't draw with the protractor 240. You're absolutely right with that. So what you do in this case is, actually, some protractors, they give you the value both in the top and the bottom. One of them less than 180, the other one more than 180. But if you don't have that kind of protractor, what you do in this case, you say, what is 360 minus 100 and minus 240? 360 minus 100, so it's going to be 120. So you draw 120 in the negative direction. That is the same thing as 240. But you have to be from the bottom, okay? Not from the top. Because if you draw 120 from the top, it's going to be not correct. It's going to be just 120. Or you draw 120 and another 120, and that's the same thing as 240. Or simply draw 120 from the bottom, and that's it. That's the same point as 240. Okay?
Okay.
So V is asking 0 degree is the same as the x-axis. Yes, 0 degree is the x-axis, always. It's the starting point, is the x-axis. Okay? Always counterclockwise. Positive is counterclockwise. Since I can do 240, I go clockwise by 120. That's the same thing as going 140, but this way. Jeffrey. Yes?
I had a question.
Yeah.
Does it matter? Because I'm noticing that we're starting with the vectors with the lowest angle. Does it matter in which can we start with the 240 and then go on to 0? Because then that would make it kind of weird, wouldn't it?
It's going to be absolutely the same answer. It's going to be the same thing. But always when you're given options between an easy option and a difficult option, try to go with the easy one, okay? Usually the first one is easier.
Okay, sounds good.
That's
Awesome.
okay. Okay, so it's going to be the same answer. Okay, Jeffrey's question, what was it then? I don't understand. 0 is the starting point. If it's 90 degrees, you go clockwise. If it's 240 degrees, you go still clockwise. Oh, right or left, it's always toward the east. Okay, toward the right. Okay. Not the other side, that's 180 degrees actually. Does this answer your question, Jeffrey? Very good, I'm glad. It clarifies, because sometimes questions when they're written, I may have something in mind and you guys, okay. So the point being in here is you have, now it gets a little bit more complicated. You have the last two, which are actually 3 vectors. So you draw the first one 100 grams at 0 degrees. You draw the second one at 50 grams with 60 degrees. You add them up. From the end of the resultant, you draw the 100 grams at 180 degrees. There is a trick with this question for and I'm going to tell you what it is to save time from once and for all. The resultant actually is going to be this one, the middle one. Because this is 100 grams, the other one is 100 grams in the bottom. This one is 0 degrees, this is 180 degrees. They will cancel each other no matter what. So what survives this sum is the middle one. But try to convince yourself graphically that that's the case, okay? Because I need to see graph for this one still. But the answer is going to be here 50, and in here it's going to be 60 degrees, because these two, they cancel, okay? And the last one is 100 grams. This is complicated. This is hard, okay? Try to think hard about it, okay? The first vector is sitting on the x-axis with 100 grams. The second vector, you go 160 degrees, which is more than 90, but less than 180 by 20 degrees. So you're almost going to 180 degrees by only 50 grams. You add this two, and you're going to find a vector. And then you're going to go with 100 grams, 215 degrees. So you're going to go in the negative direction on the other side and add it up, okay? Whatever the length of the resultant, you're going to put it in here. Whatever the measurements from fracture, you're going to give it in here. Now we're going to come with a computer sum. Usually, my recommendation for this exercise is to start with the computer sum first. That gives you a rough idea where you need to be, okay? If we're doing this in class, and if it's a calc-based class, this is lab, by the way, we do it for everybody, from intro class all the way to calc-based classes. For calc-based class, we don't give them that tool. It's not called computer. They're supposed to compute it themselves using whatever trig functions that they know. For you guys, you have a little bit of an easier way of doing it. So what you do in this case, you come to this program, and you put 100 and 0 and 190. So let's go back up to the page where we were. So the first one is 100 and 0, the second one is 190. 190. So the answers are 141.5, which is roughly 142. You're going to round it. And this is 45. So I come in here. And put 142 and 45. Very easy, isn't it? With the computer program, because you already have the computer. If we're not, I give you the actual Excel spreadsheet, which give you the same numbers. If we're not doing this online, okay? The same thing for the second vector. Okay, let me go back one more time to show you how that works for the second one. You have to remember with me, okay? Or at least somebody writes them down. So we're gonna write 50 grams, 50 degrees, the first one, 100 grams, 165 degrees. So 50, 50, 100, 165. So come back in here. Okay, I don't like this. My computer frozen, and not this thing frozen here on me.
After using the Acrobat,
it hangs a little bit. Okay. Let me go. Okay, very good. So we said 50, 50. So I'm going to delete this and make it 50. At
I did
50,
it, and I got 148.9, and then 60 in the next one.
okay. So let me put 100 and, how much was it? 100 at what angle? 165?
Oh, I put 65, sorry.
It should be 165.
Okay.
Okay. Okay. So the answer is 91 grams is the sum and 135. So I come back in here and put 91 and 135. You guys see the rule? Let me take one of this, just the one I told you where to expect the results, okay? 100 and 0, 50 and 60, 100 and 180. So this would be 100 and 0. So I'm going to be 100. This is 0. Notice how the values are changing right away for me. And this is 100 also, but it's 180 now. 180. Oops, 1,800. That's not good. Make sure you enter the data correctly. And the middle table, what is it? And 50, 60. 50. And then 60. Roughly, I mean, because there are some errors in the calculations, this is actually JavaScript behind the scene, and it rounds and does all kinds of stuff in there. And actually, the value of pi, that's why you have to keep 3 sig figs. The value of pi, I hard coded it to be 3.14 in here, okay? So that's why you have to keep 3 sig figs. In here, it's giving you 50.1. It actually should be 50, and 60.1 should be 60. So I come in here and put 50, 60. Do you guys understand how this should be done quickly? It should not take time to do. Yes?
Yes.
Okay,
Yep.
so that gives you an idea where things are headed then. From there, it should help you with the graphical method now. Okay? From there, if you're going to go and do graphs, you know where the sum is going to end up. Based on the middle 2 columns. You know where the sum is going to end up being. And that's what we recommend, even in the face-to-face. We tell them, okay, forget about the graphical method right now. It's kind of messy and you want to do it right. So do the computation first. Calculate this thing first, okay? Find where the resultant need to be. The computer will give you the resultant, okay? Find it. Once you find it, then you know where the sum is going to be. Does this sound like it's a good working plan? So you need to fill this part first. Yes?
Yes.
Okay. Then what we do, we skip the force table, we skip these 2 columns, and we go to the equilibrant method. Okay? We go to the last 2 columns. So in the lab, this is how we proceed. Look, I'm trying to give you a feel of how the lab is, so that when you walk tomorrow to the lab, if they tell you, you know what, you're going to the lab, you will have the same experience as much as you're doing it online there, so that you will have a full experience of what the lab look like, okay? So, in the lab, we start with this column, and then we jump into these 2 columns, okay? So let's do these 2 columns, the first 2, and then we jump into this. Once we're done with this, then we do this ones, okay? And then once we fill all of this, then usually this is done at home. I ask my students to fill it at home, bring it, okay? Because this is tedious a little bit and requires a little bit of focus on how to do that. So the graphical method that we start with, we leave it toward the end, okay? Okay, so now we're gonna go to the force table. So let me go into the instructions. There are some questions in here that need to be answered besides force, what other quantities. So you need to think of other vectors and other scalars. So you need to come up with something. Can you add velocity vector to a displacement vector? And you should think of why that is not possible, okay? So you should have a reason why this is not good, okay? And those are the questions. Those are the only questions. Then don't forget you have a conclusion and you have also an objective that you need to fill, okay? So let's do now this part. So where is the link for it? Here is a link. So I'm going to click on it for the graphical method. And I'm going to stop sharing that screen. And now share with you the new screen. Share. Let me see first of all what is out there. Okay, that's fine. So where is the share? It takes me to the GeoGebra basically link, and it tells you in here what to do. Enter the value of the weights in grams and their directions. Enter the value of the equilibrium of 10 grams. This is the trouble with the lab. When we do the lab, fine grams are expensive. So labs usually they carry only 10 grams or 100 grams or 50 grams, but they don't have 1 gram, for example. Okay, so some of the tables it says 142 grams. How are you going to do 142 grams if you can only do 100 grams or 140 grams? So you can't do 142 grams. So in here, it has to be in increments of 10. You cannot put a number in here 142, because if you put it, it's not going to work for you. Okay, that's one thing. This is how the force table look like. If you tomorrow walk into the lab and you see something like this, you know exactly what lab that is. This is the force table. For the first experiment, for the first where you add up 3 vectors, you don't use one of the other pulleys. You just remove the mass off of it, and you use only 2 pulleys and the resultant. So you use 3 pulleys basically at that point. What you have in here, you have rings. You have a ring in here attached to strings. The strings are going through a pulley where the masses are hanging in there. This is where your 100 grams goes, or 50 grams goes, or whatever grams you're asked to put in there. Okay, this is where they go. Okay, so to go back into my initial example, it says I need to put 100 grams. Let's say one of them is 100 grams, doesn't matter. So I'm assuming one of them doesn't have anything. So this is not interactive. This is when the interaction is. I put 100 grams in here, and I put another 50 grams at an 80-degree angle. There are angles in here from 0 to 360. Okay, I have to put them. I have to be very careful in here to put one of them at 0 degrees and the other one at 80 degrees. And I put 50 grams in there. The third one, I remove all the weights off of it. According to my table, let me stop this one in here and go back into the table. According to my table, these 2 vectors add up to 120 grams roughly. Okay, I found 120 grams. According to the computer, it should be about 119. I cannot do 119, remember? I have to do 120. So in here, I'm gonna put 120, okay, in the equilibrium. Now, the sum, according to the computer, it says 24 degrees, okay? 24 degrees, yes? So this is their sum. They add up to 24 degrees. I have to go 180 degrees more to balance this. So I have to add 24, add to it 180 to make it to 204. So let me stop sharing the screen. Go back into my other screen. So the equilibrium, not the resultant. The resultant is here somewhere. Okay, that's where the resultant of the 2 forces is. This one has to be opposite to it by 180 degrees. So I put 180 degree, 120. That's the weight I'm going to put in here, and I put the direction. Let's say, for example, I don't put it at 204. Let's put it, for example, at 230. Okay, no equilibrium. The ring will move one way or the other, and this ring touches this support. You want it to be free. You don't want to touch. Okay, so this is how the lab works. So if I put it at 204 degrees, I'm going to be back in the free ring. The ring is free, actually. You have equilibrium. Let's say, for example, I don't put 120. I'm going to put 140 grams in there, okay? It's too much mass. It's going to pull it toward it. You guys understand that? So I have to use whatever value in here. Let me go back to the actual table. This is why the calculation is very critical to do it first, okay? If we're going to do this lab. This is why it's helpful to have these numbers. Okay? So whatever the sum is in here, what did we say the sum is in here? Do you guys remember? So it was 100, and this is 0. No, this is 90, and this was 0 actually. It doesn't matter the direction. If it's 0 force, it's 0 force. So it was 141.5. So remember, I'm going to put 140 here. I cannot put 141.5. I can't do that. There is not enough grams. We have only 10 grams. So we're going to put 140 grams. And in here, it says 45 degrees here. Okay, remember? This is 141 or 142 roughly. And this would be, what was it? 45 degrees. So here, it's going to be 140. And in here, I'm going to try 180 plus 45. Because if the resultant is at 45 degrees, so I have to go 180 on top of that, on the opposite side, to balance it, to balance the resultant. So in this case, 180, so that should be 225, correct? So that's basically how much the value should be. Now, I go back into my table, into my force table. Let me go back into the force table. So for 100 and for 90 degrees, the sum was 140 actually. And the direction was 225. Now it balances, okay? So I report this number on the equilibrium. You guys understand how this is working? Yes? Okay, we have one confirmation. So basically you have to go with the calculated, and you have to go on the opposite side of the resultant to find the balance. And because there is a built-in error, because there is friction actually in the lab, you will find that you have to adjust the angle a little bit. Okay, let me show you what I'm talking about. Okay, let me stop sharing this thing in here. Let me put 226 degrees and see if that works. It's still free ring. Let me put 220 degrees. No equilibrium. Let me put 221 degrees. So there is a leeway. Even in the lab, there is a leeway because of friction. Okay? So 200, if somebody puts 221, it's perfectly fine. Because even in the lab, that happens. So I'm going to put 229, for example, and see if that's going to work. It's going to work. 230 and see if it's not going to work. So as long as I have this condition, it's working. Let's say, for example, I have put 150 grams in here. No, it's not going to work. 225 degrees? No, it's not going to work. So this one is not going to work for me for 100. Let's put 130 grams. It's not going to work. So this works with 140 grams, okay? That's why even in the lab, there is that leeway. Even if we are in the classroom and we're doing this lab, 180, Jeffrey, it's 180. Now, if you end up with a negative number, you have to add the 360. 180 is opposite. So if the resultant is this way, you want to come to it from the other side, like a tug of war. Yes, Jeffrey? So it's 180. Unless if you add 180, it ends up to be more than 360, then you actually subtract 180. So it's either add or subtract 180, that's all. Okay?
You're just trying to get that middle part back into the center, right? Like that's
yes, you don't want it to move. You don't want it to move. The middle part has to stay in there. From the resultant, Amanda, yes, you're correct. From the resultant, if you add 180 and it goes more than 360, on the force table, there is nothing more than 360. So you actually have to subtract 180. Either go one way or the other way of 180. Basically, if this is the force is pointing down, and if I try to go to it, it's going to end up more than 360. So I have to go in the opposite direction, subtract 180, that's it. As long as the equilibrant is between 0 and 360, you're in good shape. You're balancing it, okay? but you know where you're going to get those values for the equilibrium. You're going to get them from the computed values. The value for the force itself is within 10 grams, whatever the other one is. So if it's 142 or 147 or whatever, 118, you have to approximate to the nearest 10. That's one thing. Then the angle, either you go 180 more or 180 less, as long as you're between 0 and 360. And that's what we do in the lab. This is the lab in essence. Now you're asking me, okay, we did this, that's great. We know we have done this middle part using the computer. We have done this part in here, relying on this data, getting the numbers in here and confirming that I have equilibrium through the link that you gave us. That's great. I know how to handle this part because I have to go and use protractor and ruler and basically sweat through it, and maybe at some point the pencil will break and you know the fun stuff. Okay. How about the middle one? How about this force table? Well, the force table is coming actually from those data. This is the equilibrium. Your goal actually is not the equilibrium. Your goal is actually the resultant. But from this numbers, not from any of the other numbers, from only the equilibrium. Now you take whatever value you have in here and you write it back in here. Remember, it may be different than this value. So if this was 140, you write it back in here, okay? And you add or subtract 180 from this number as close as possible from this one. For this case, it's going to be exactly a match, 45, and here it's going to be 140. Okay, so this is easy now. The biggest part actually in terms of doing work is this part, and that is coming immediately from what you compute in here, which is easy enough to do. Okay, and then this part you have to go back into the link for the GeoGebra and get your numbers in here. These numbers, remember, they have to be multiples of 10. This number, they may be slightly more or less than this numbers, plus 180 or minus 180, depending on what you end up with. And this number, they will be exactly the same as this entire column in here for the magnitude from the equilibrium, and the magnitude of the sum, they will be the same thing. It's this one that are off by 180 degrees versus this one. This one and this one will be close, okay? They may be within a degree or two off, okay? This is the computed. Now, the last part you're supposed to do, which was the first part we started with, was to go back and redraw these things. That's your lab. That's what we would do if we were in class. Does this sound fun?
Very fun.
Okay.
Because at the end we have to basically go through all these problems, take pictures of them, and send them over to you, like add them to the
yes,
assignment, right?
Yes, I would like you guys to really do this thing honestly, because my goal is really forget about the grades. I think you're going to get your grades if you do everything, but it's really to learn from this different ways of doing this summations, and hopefully you come up with something tangible. Although we're not meeting in person, but you're still really honestly working your grade. I mean, you're working your concepts and learning stuff from this class.
Yeah,
okay?
It's a little difficult when we're doing it over or through online, you know, and trying to read through the whole thing and then email and do all that. But yeah.
Okay, I am here basically almost all the time. So if you guys have a question, please do ask it. The last thing I would hate you to be stuck in one thing, trying to figure out after even an hour through it is too much. Okay, just shoot me an email or send me a message, and we'll go to live together. And we'll be more than happy to record that for the rest of everybody else to see it, and make sure that you move past that point. Okay, make sure you're not stuck in that point. Okay.
Okay.
Okay, so you're supposed to be continuing this activities now, working on it. We end the class really at 9:10. So don't forget that there is a prompt after this one, and the prompt has to do basically with the pictures. So you optimize the picture. That's the question that we want to have done for it, because you'll be submitting all of those graphical things in there with the scale. Don't forget the scale. It's a critical piece of information in there. And it should work. Any questions?
Sorry, what do you mean by the scale again?
Okay, let me go back into the picture because it's a critical part. Okay, if you miss that one, you're gonna have difficulty with your lab.
Oh, the 10 grams equals to
yes.
like a centimeter. Oh, okay.
This part.
I see.
Okay. That
Okay.
gives me actually an indicator that you actually did it correctly, okay?
Right.
So this part, this is the scale with the ruler on top of it to make sure that I can basically, because there are technicals, the methods basically to compare this length for me with this one to make sure that roughly you had the actual correct numbers in there. Okay. And even if we were in person, basically, when I ask people to go and do this and at home, I require the scale. Okay, I require the scale. That's part of the lab itself. You have to have the scale too.
Okay.
Okay.
I did have a question.
Yes.
Would we be able to just stay on this Zoom call with the other students, and then in case we had any questions, or
Sure. You
okay.
guys want to break into sessions with the preferred group, or do you want to stay all of you in together in here? Because
I don't mind staying with everybody.
okay, if you guys don't hear me, because I'm gonna remove my speaker basically from my ears, so I will not probably hear you if you guys have a question. But send me a message on Pronto or something. It comes actually to my watch, so I can immediately be notified of what it is. But I trust that you guys have fun with this and start working on it. Okay?
Cool.
But I'm gonna stop the recording right now, so that whatever you guys do and talk is not really included in here. Okay? That's fine?
Cool. Sounds good.
Okay.